Hey, it's me, Tony the Triangle. Tell me again, talking about congruent triangles. Me and my boy Tinky Winky. Hey, Tinky! Yeah, what's up?
First thing we're going to talk about are congruent polygons. So two polygons are congruent if and only if their corresponding parts are congruent. So here we have two triangles down here. And we know these two triangles are congruent because their corresponding parts are congruent. And by corresponding parts, we're talking about their corresponding angles and their corresponding sides. So let's first look at the angles. Their corresponding angles. Angle A is congruent to angle D. Angle B is congruent to angle E. And angle C is congruent to angle F. Same thing with the corresponding sides. Segment AB or BA is congruent to segment DE or ED. Segment BC or CB is congruent to segment EF or FE. And segment AC or CA is congruent to segment DF or FD. Now that we know all the corresponding angles and corresponding sides are congruent between these two triangles, we know that these two triangles themselves are congruent. And we create this congruent statement. And below it, I have in bold, red, underlined letters, order matters, because it does. It matters. Why does it matter? Because just from this congruent statement, you can tell that angle A is congruent to angle D, angle B is congruent to angle E, angle C is congruent to angle F. Segment AB is congruent to segment DE. Segment BC is congruent to segment EF, and segment AC is congruent to segment DF. Just from this congruent statement. And the reason for that is because of the order it's in. What you could do, though, is rename the first triangle. That just means you would say triangle CBA would have to be congruent to triangle FED, because the order matters. Now, the third angles theorem says if two angles of one triangle are congruent to two angles of a second triangle, then the third angles of the triangles are congruent. So here we have triangle JKL and triangle QMP. And we know from the markings in these two triangles that angle J is congruent to angle Q. Angle K is congruent to angle M. And because we know two angles in one triangle are congruent to two angles in another triangle, those third angles, angle L and angle P, must be congruent to each other. And it makes sense because if you think about the triangle angle sum theorem, you only have 180 degrees. And if you take away this angle and this angle, then all that's left is the measure of angle L. And if you have the same measures over here that you take away from 180 degrees, it's going to be the same measure for angle P. Therefore, angle L must be congruent to angle P. Now, there are 5 right angle theorems that I want to talk about as well. The first says perpendicular lines intersect to form 4 right angles. And we kind of already knew this, right? If we have line AC and line DB, and we know those two lines are perpendicular to one another, then we know that angle 1, angle 2, angle 3, and angle 4 must be right angles because perpendicular lines intersect to form 4 right angles. The second right angle theorem says all right angles are congruent. So this is just saying that if you know two angles are right angles, then those two angles must be congruent. And that should be pretty obvious because the measure of a right angle is 90 degrees. And if another angle's measure is 90 degrees, then those two angles must be congruent to each other. The third right angle theorem says perpendicular lines form congruent adjacent angles. So here, line AC and line DB are perpendicular. Therefore, angle 1 and angle 2 are congruent and adjacent because both of them are right angles. Both of their measures are 90 degrees. Therefore, they are congruent and they're adjacent because they share the side. Same thing with angle 2 and angle 3. They are adjacent because they share the side, and they're congruent because they're both right angles. Same thing with angles 3 and 4. Same thing with angles 4 and 1. The fourth right angle theorem says if two angles are congruent and supplementary, then each angle is right. This should also make sense. Let's look at angle 1 and angle 2. If we know angle 1 and angle 2 are supplementary, that means that their measures add up to 180 degrees. If we know they're supplementary and we know they're congruent, that means you just take 180 and divide it by 2, which means that each measure would equal 90 degrees, meaning that each angle would be a right angle. The fifth right angle theorem says if two congruent angles form a linear pair, then they are right angles. So let's look at angles 3 and 4. You could look at any adjacent angles up here, but we're going to look at angle 3 and angle 4. They are adjacent angles and they form a straight line. Therefore, they are a linear pair, which means that they're supplementary by the supplement theorem, which means that their measures add up to 180 degrees. If we also know that they are congruent, then we know that their measures have to be equal. So we just take 180 and divide it by 2, and each of their measures must be 90 degrees. Therefore, they are right angles. That's how that works.
Bright lights, New York City. Example time.
Now, example 1 says show that the polygons are congruent by identifying all congruent corresponding parts. Then write a congruent statement. So remember, when we're talking about congruent corresponding parts, we're talking about all the corresponding angles and all the corresponding sides. So let's first look at the corresponding angles. So because angle L has one arc right here, we know that it must be congruent to angle H, which also has one arc over here. Because angle M has two arcs over here, we know that it must be congruent to angle J because it has two arcs over here. Because angle N has three arcs over here, we know that it must be congruent to angle I, which also has three arcs over here. So those are all of our corresponding angles that we know are congruent because we know these two triangles are congruent. Now let's look at the corresponding sides. So which corresponding sides are congruent? Well, we know that segment LM or ML has one tick mark. Therefore, it's congruent to segment HJ or JH because it also has one tick mark. We know that segment LN or NL has two tick marks. Therefore, it's congruent to segment HI or IH because that also has two tick marks. Lastly, because segment MN or NM has three tick marks, we know it must be congruent to segment JI or IJ because that also has three tick marks. Because the corresponding angles and corresponding sides of both triangles are congruent, we can then create a congruent statement. Now, there are a couple different ways you could write this, but remember the order matters. I'm going to go in numerical order based on the number of arc marks for each vertex. So here, I'm going to go triangle LMN is congruent to triangle HJI. And we know this because all the corresponding angles and corresponding sides are congruent. Again, for our congruent statement, order matters. Just from this congruent statement, we can tell that angle L has to be congruent to angle H, angle M has to be congruent to angle J, angle N has to be congruent to angle I. We know that segment LM must be congruent to segment HJ, segment MN must be congruent to segment JI, and segment LN must be congruent to segment HI. You didn't have to start with triangle LMN. You could have said triangle NML is congruent to triangle IJH. You could have said triangle MLN is congruent to triangle JHI. Both of those work. You just have to make sure that the vertices that are congruent match up.
Hey, I'm watching a Yankee game. I can't do it. You try.
Okay, doing the same thing. So first, we want to show that the polygons are congruent by identifying all congruent corresponding parts. So when we're talking about corresponding parts, again, we're talking about corresponding angles and corresponding sides. So let's identify all the congruent corresponding angles first. So you can see in both of these triangles, we have a right angle. And we just learned from our right angles theorem that all right angles are congruent. So we could say that angle J has to be congruent to angle Q. Over here, angle K has one arc mark, so we know that it must be congruent to angle M, which also has one arc mark. Angle L has two arc marks, therefore we know it must be congruent to angle P, which also has two arc marks. So we've stated all of the corresponding angles that we know are congruent. We can then move on to the corresponding sides. Let's start with one tick mark over here. We know that segment JK or KJ has one tick mark, therefore it must be congruent to segment QM or MQ, because that also has one tick mark. In this triangle, segment KL or LK has two tick marks, therefore it must be congruent to segment PM or MP over here because that also has two tick marks. Segment JL or LJ over here has three tick marks, therefore it must be congruent to segment PQ or QP, which has three tick marks. So we have now stated that all corresponding angles are congruent and all corresponding sides are congruent. Therefore, we can create a congruent statement and say that triangle JKL is congruent to triangle QMP. Don't forget, order matters. The reason we stated it in this order is because angle J is congruent to angle Q, angle K is congruent to angle M, angle L is congruent to angle P, segment JK is congruent to segment QM, segment KL is congruent to segment MP, and segment JL is congruent to segment QP. There's a reason it's in this order. Make sure you know order matters. Now, example 2 says, given that triangle GHF is congruent to triangle MQP, find the values of X and Y. So down here, we have triangle GHF congruent to triangle MQP. Let's look at what we're given. We're given two angles in this triangle and one angle in this triangle. We're given two of the sides in this triangle and one of the sides over here. Now we need to find both X and Y. And normally you just be like, all right, let's find X first because it's alphabetically first. But the only time x appears is in this expression right here, which also has a y in it. And if you look, there's no other x's that we can solve for. But here, there's a y that's by itself. So we can actually create an equation and find y first. So let's do that. How can we set up an equation to solve for y? Well, we know, based on this congruent statement, that angle G is congruent to angle M, angle H is congruent to angle Q, angle F is congruent to angle P, segment GH is congruent to segment MQ, segment HF is congruent to segment QP, and segment GF is congruent to segment MP. So if angle P has the y in it, which angle is angle P congruent to? That would be angle F. And we know that just from the congruent statement. We didn't even need any of the markings that we had in the previous examples. So we can now say that based on our congruent statement, angle P has to be congruent to angle F. Now we can set up an equation where the measure of angle P is equal to the measure of angle F by the definition of congruent angles. Oh, we aren't given the measure of angle F. Well, we are given two angles of a triangle. And based on the triangle angle sum theorem, we could just take 180 degrees, subtract 45 degrees, subtract 36 degrees, and you're left with 99 degrees. So we know the measure of angle F has to be 99 degrees. So we're going to take 99 degrees, plug it in for the measure of angle F, take 8y minus 5, plug it in for the measure of angle P. Now we have an equation where we can solve for y. So let's go ahead and add 5 to both sides, divide both sides by 8 to get y all by itself, and we end up getting that y is equal to 13. Sweet, we found y. Now we can set up an equation to find x. So again, the only place x appears is for the measure of segment QP. So segment QP, from our congruent statement, we know must be congruent to segment HF. So where's that? That's right here. Oh, perfect, we're given that. So we can say that segment QP must be congruent to segment HF. Again, that's just from the congruent statement. That's why order matters. Next, because we know that they're congruent, we know that their measures must be equal to each other by the definition of congruent segments. Then we can substitute in what those measures are. The measure of QP is 2y plus x, so that goes in here. The measure of HF is 38.4, that's going to go in here. We can now solve for x. Oh, we got a y in here though. We figured out what y is already. We take that 13 that y is equal to, plug it in here. Now we can solve for x. So what is 2 times 13? That's 26. Then we get x all by itself by subtracting 26 on both sides, and we get x is equal to 12.4. And we found x and y. Done.
Hey, I got a pizza on the way. You try.
Okay, doing the same thing. Here, we are given that triangle ABC is congruent to triangle GFE, and we need to find the values of x and y. So, we need to figure out, are we going to find x or y first? Well, it looks like the measure of segment FE, if we're looking right here, has both x and y in it. We don't want to set up an equation with that because we won't be able to find x or y. We'll still have a variable left. What about here? Yeah, the measure of angle E has 2x in it, so that means we want to find x first because it's by itself. That'll help us. Okay, so let's find x. Now, how do we set up an equation? What is angle E congruent to? Well, if you look at our congruent statement, remember, order matters. This is telling us that angle A is congruent to angle G, angle B is congruent to angle F, and angle C must be congruent to angle E. Okay, perfect. So we're going to say that angle C must be congruent to angle E. Now we can say, because they're congruent, that their measures must be equal to each other by the definition of congruent angles. We then can plug in what those measures are equal to. The measure of angle C, we see, is 78.3 degrees, so we plug that in here. And the measure of angle E is 2x degrees, so we plug that in here. We can then solve for x. So let's divide both sides by 2 to get x all by itself, and we end up getting that x is equal to 39.15. Because we have found x, we can now find y. We said earlier that the measure of segment FE or EF is 3y minus x. That's where y appears in this problem. So how do we set up an equation with this? What is segment FE or EF congruent to? Well, if we look back at our congruent statement, segment FE must be congruent to segment BC. Remember, order matters. That's what it's telling us. And because of that, we know that their measures must be equal to each other by the definition of congruent segments. Then all we have to do is just plug in what those measures are. The measure of segment BC, is 35.8, so we plug that in here. The measure of segment FE or EF, we said, is 3y minus x, so we plug that in here. Now again, there's two variables. How do I solve for y? Well, I already know x. It's 39.15. So I plug that in here. And now I can solve for y. So let's get y by itself by adding 39.15 to both sides, dividing both sides by 3, and we end up getting that y is approximately equal to 24.98. Now, why did we round to the nearest hundredth? Because that's what the problem required. We have found x and y, therefore we are done. Now, example 3, we have a geometric proof with a given and what we're trying to prove. So, again, in a geometric proof, the very first step is to mark up the figure with the given information. So what are we given? We're given that segment DE is congruent to segment GE. We're given that segment DF is congruent to segment GF. And we're given that angle D is congruent to angle G. Lastly, we're given that angle DFE, angle DFE would be this angle right here, is congruent to angle GFE, this angle right here. So step 1 is done. Step 2 in a geometric proof is to state the given. It's going to be your first step. So the given is segment DE is congruent to segment GE, segment DF is congruent to segment GF, angle D is congruent to angle G, angle DFE is congruent to angle GFE. And again, the reason for that, it's given. Next, we need to come up with a game plan. How are we going to show that these two triangles, triangle DEF and triangle GEF, are congruent to each other? Well, we already have two angles congruent over here and two angles congruent over here. We have two sides congruent over here and two sides congruent over here. To get two triangles congruent, we need all three angles congruent to all three angles and all three sides congruent to all three sides. So let's start with the sides. Since we know two of the sides are congruent, the third side, they actually share. Both triangles have segment EF in them. Therefore, we can say that segment EF is congruent to segment EF itself by the reflexive property. Now we have all three sides in both triangles congruent. What about the angles? Well, how do I get this third angle in both of the triangles congruent? If you recall, the third angles theorem says if two angles in one triangle are congruent to two angles in the other triangle, then the third angles must be congruent. Therefore, we have shown that the corresponding sides in each triangle are congruent and the corresponding angles in each triangle are congruent. Therefore, the triangles would be congruent. So that's how we're going to do this. First, we said we wanted to talk about this side length. Segment EF is shared by both triangles. Therefore, you can say segment EF is congruent to segment EF. And that is the reflexive property. Anytime something is congruent to itself or equal to itself, that's the reflexive property. Next, we said that since two angles in one triangle are congruent to two angles in another triangle, that these two angles, the third angles, angle DEF and angle GEF, must be congruent by the third angles theorem. Lastly, since we've shown that all the corresponding sides and all the corresponding angles are congruent, we can say that the two triangles must be congruent by the definition of congruent polygons, which we stated earlier. Two polygons are congruent if and only if their corresponding parts are congruent.
Hey, it's the city that never sleeps, so you never sleep by doing this you try.
Okay, we got another geometric proof. So first step in a geometric proof is to mark up the figure with the given information. So what are we given? We're given that segment BD right here, bisects angle ABC, angle ABC. So what does bisect mean? Bi means two, sect means cut. So segment BD is going to cut angle ABC into two equal parts, meaning that angle ABD is going to be congruent to angle CBD by the definition of angle bisector. So that's something we're going to have to state later on in our proof. We also are given that segment BD is perpendicular to segment AC. So segment BD is perpendicular to segment AC. Well, what do we know about perpendicular lines or perpendicular segments? They form right angles. So both of these angles must then be right by the definition of perpendicular lines. Again, that's something we're going to have to state down here. Next, step 2 in a geometric proof, we need to state the given. So that's going to be the first statement and reason. So what are we given? We're given that segment BD bisects angle ABC, and we're given that segment BD is perpendicular to segment AC. The reason for that, again, it's given. Now, step 3, we got to come up with a game plan. Use some problem-solving techniques to get from what we're given to what we're trying to prove. So how do we do that? Well, again, we said that segment BD bisects angle ABC. So we can say that these two angles are congruent by the definition of angle bisector. We then know that these two segments are perpendicular to one another. Therefore, these must be right angles by the definition of perpendicular lines. We can then say because they are both right angles, they must be congruent because all right angles must be congruent. That was one of the right angles theorems we talked about earlier. Then, because two angles in one triangle are congruent to two angles in another triangle, the third angles, angle A and angle C, must be congruent to each other by the third angles theorem. Cool, that's what we're going to do. So, after our given, we're going to write that because segment BD bisects angle ABC, angle ABD and angle CBD must be congruent to each other by the definition of angle bisector, which says that if an angle is bisected, it forms two congruent angles. We can then say that since segment BD and segment AC are perpendicular to one another, that these angles that they meet at, angle ADB and angle CDB, must be right angles by the definition of perpendicular lines, which says perpendicular lines meet at right angles. Then, because these two angles are right angles, we know that they must be congruent because, we said earlier in the right angles theorems, all right angles are congruent. Lastly, because we've shown that two angles in one triangle are congruent to two angles in another triangle, then the third angles, angle A and angle C, must be congruent by the third angles theorem. And you're done.